Okay, with those definitions in mind, supplementary, complementary, angles, vertical angles, and linear pair, let's look at some examples. I'm going to ask you several times to pause the video and try some of these on your own. So please do that. Please don't just continue watching. If I ask you to pause the video and try something on your own, pause the video, take some time, try and figure it out on your own, and then replay the video to see the solution to that problem. That's the best way this will work for you to help you practice. So let's take a look at an example. Okay, here is a diagram of some angles. And what I want to know is if in this diagram, are there any linear pairs and are there any vertical angles? Okay, so take some time and I just want you to, and you can just list them up here. You can just say this angle, and I'm going to zoom out so that we can get all of this in the, okay. You can just write on your notes, this angle and this angle are a linear pair. This angle and this angle are a linear pair. And then the same with the vertical angles. Okay, so I want you to pause the video, take some time, and try and see if you can spot any linear pairs and any vertical angles. Okay, hopefully you've had some time to do that. Let's talk about this. Let's do the linear pairs first. Well, we need to remind ourselves first what the definition of a linear pair is in order to answer this. What is the definition of a linear pair? Well, as we saw up here, I'm going to go back a slide. A linear pair is a pair of adjacent angles. That should say angles. A pair of adjacent angles that are supplementary. A pair of adjacent angles that are supplementary. So, do you see any adjacent angles that are supplementary whose sum is 180? Well, angle 1 and angle 2, if I add them together, it looks like they form a straight angle there, which looks like it's about 180. So I would say angle 1 and angle 2 is one linear pair. Do you see any others? What about, let's just go around. So 1 and 2. What about 2 and 4? No, this angle here looks like it's bigger than 180, so that's not going to be a linear pair. Okay, what about 3 and 4? Yes, that looks like it's a straight angle right there. So we have a perfect example of two adjacent angles that are supplementary, that add to 180. So I'd say angle 3 and angle 4 also forms a linear pair. And then let's look at 1 and 3. No, this angle right here does not look like it's 180. So it looks like 1 and 2 and 3 and 4 are our only linear pairs here. Now, any vertical angles. Okay, let's talk about that. In the definition of vertical angles, remember, what was the stipulation? The stipulation was the pairs of opposite angles formed by two intersecting lines. Well, if you look at our picture here, there aren't two intersecting lines. A line is a collection of points that goes in two directions. So we have one line right here. This is a line because it goes off in the two opposite directions. So that is a line. But this is a ray, and clearly it does not extend off in the exact opposite direction, so that's not a line. And this is also its own ray, so that is not a line. So in this diagram, we actually don't have any vertical angles because this isn't two intersecting lines. So none of these angles are vertical. Okay, so let's move on. Okay, what if I was to ask you to use what you know about linear pairs and vertical angles to solve for x and for y? We're going to do an example together first, and then I'm going to show you another example, and I want you to do it on your own. Okay. First of all, we need to take a look at these angles and see what we know. Two intersecting lines. Are there any vertical angles? Are there any linear pairs? Because if we know that two angles are vertical angles, we know that they are congruent, right? Because VARC, vertical angles are congruent. And we know that linear pairs add to 180. I'll just write LP. LP add to 180. So if we can spot any vertical angles and any linear pairs, then right away we can know something about these angles, set them up to solve. So let's look at our picture here. Clearly, there are actually four linear pairs here. Here is one. This angle and this angle is one linear pair. Why? Because they're two adjacent angles. They share a side, and they clearly add to 180. They're supplementary. Okay. Here's another pair. Get rid of those dots. This is a linear pair, and this is those two angles are a linear pair. These two angles are a linear pair, and these two angles are a linear pair. Okay, so let's see if we can use that fact to set up any equations to solve. So, for example, let's take a look at these two angles. Given that they are a linear pair, what do we know about them? Well, we know that they add to 180. So if this angle is y plus 20, then we know y plus 20 plus 3x plus 5 equals 180. Now, here's the thing. Look at that. Does that help us solve for either x and y? You might think that it does at first, but at a closer look, it actually doesn't. Why? Because we can't solve an equation that has two variables in it. We can only solve equations that have one variable. So when we're looking at which linear pairs to use, we actually need to look at the linear pairs that share the same variable. So, for example, here is a linear pair, this angle and this angle, that both have x in it. So with that, we can set up 3x plus 5 plus x plus 15 equals 180. Okay, equals 180. Now you might be looking and you might be saying, well, why didn't we use the fact that vertical angles are congruent here to solve? Well, look, we could have done that because we also have examples of vertical angles here in this picture. What do I mean by that? Remember, our opposite angles when two lines intersect are going to be vertical angles, and vertical angles are congruent. So this angle is congruent to this angle because those are opposite angles, and this angle is congruent to this angle because those are opposite angles. But if I were to set up, so how would I set up equations with those angles and solve? Well, if this is congruent to this, then that means 3x plus 5 is equal to 4y minus 15. But once again, look, that's an equation that has two separate variables, so I can't solve it. So it doesn't really help me that I know these are vertical angles, because if you look at, for example, if you look at the other pair of vertical angles here, those also do not share. They have different variables. This one has x and this one has y. So vertical angles in this specific diagram don't really help us. But if this angle and this angle were both x or were both y, then that would be extremely useful to be able to use that to solve. So let's work this out and let's solve for x. Get on to it. 3x plus x is 4x. 5 plus 15 is 20. That equals 180. So I need to subtract 20 from each side, so I'm going to do that. This side, all that will be left is 4x, and 180 minus 20 is 160. And so x is 40. Okay, and we're not done because now I need to solve for y. So we can do the same thing for these two angles. This angle and this angle form a linear pair, so we know that that means that y plus 20 plus 4y minus 15 equals 180. And I want you to go ahead and pause this video and solve this on your own, and I will work it out here as well. Y plus 4y is 5y. 20 minus 15 is 5. That equals 180, so I need to subtract 5 from both sides, and I get 5y equals 175. And when I divide 175 by 5, hang on, I have to do this in my head really quickly. 5 goes into 120 times, and 5 goes into 75, 12, 13, 14, 15 times. So y is 35. So there you go. We've used the fact that there are vertical angles and linear pairs here to solve for x and for y. So here is another example of this, and you have this in your notes. And what I want you to do is I want you to use vertical angles and linear pairs to set up equations to be able to solve for x, y, and z here. And what I want you to do is, before you move on, I want you to pause the video, do this, and you're actually going to come and show me your notes to show me that you get this. So when you have solved for x, y, and z, come check it with me, and then when you have checked it with me, you can move on. Okay, so if you have not completed this problem and shown me X, Y, and Z, you need to pause the video and do that now. If you have done this, then we will continue on with a couple more with one more example, and then we will be done. Here is the example. If angle A is the complement of angle B and angle A is the supplement of angle C, then find the measure of angles B and C if the measure of angle A is 31. Wow, that is a lot of words. Let's dissect this. If angle A is the complement of angle B, what does that mean? Here is what that means. What does it mean for two angles to be complements? It means that when I add those two angles together, let's go back in our notes and find it. When I add those two angles together, complementary angles mean that two angles who sum to 90. So here, if I add the two angles together, if angle A is the complement of angle B, that means when I add them together, they are 90. Okay? If angle A is the supplement of angle C, what does that mean? Well, clearly that is the other one. So the measure of angle A is supplementary to angle C. So that means when I add them together, they are supplementary, which is 180. Then find the measure of angles B and C if the measure of angle A is 31. So I actually can plug in here and replace the measure of angle A with 31. So I'm going to do that. And in where it says measure of angle A, I'm going to replace it in each of those cases with 31, since we know that. The problem is giving us that the measure of angle A is 31 degrees. And then I need to do some solving. How are we going to solve this? Well, when you're solving problems like this, you just treat this entire thing as if it's its own variable. So if we treat this like it's its own variable, I'm going to come down here and solve this. Then what I need to do is I need to subtract 31 from each side, because this is a positive 31 and I need to get this variable by itself. So I'm going to subtract 31 from each side, and when I do that, all that will be left on the left side of this equation is the measure of angle B. And over here I need to do 90 minus 31, which is 59 degrees. And so let's actually look at what the statement says. What the statement says is the measure of angle B equals 59 degrees. So we know what angle B is. And now here, I'm going to move down here, we can do the same thing. We are going to treat this as if it's its own variable and get it by itself and solve. So once again, I need to subtract 31 from each side, and you would get on the left side, all that would be left is measure of angle C, and that equals, over here would be 180 minus 31, which is 149 degrees. Okay, so even when we don't have a picture, when it's written out, if we just go with our definitions of what these words mean, we can use this to solve for some values. We can solve, here we solve for the measure of angle B being 59 and the measure of angle C being 149. So that is vertical angles and linear pairs. Really not that complicated, and you can use them to solve a lot. So now what you're going to do is you have a set of practice problems in your book that you need to do. Do those practice problems, check them with me, and then you can move on to the next section, the last section, chapter 1, section 7.